Okay, guys, this is a great question asked. It's from a 2009 exam. Even though it's old, it's a little bit out of date, but this question could easily pop up in your exam because it is a fantastic question. Really common question as well. It's common because it's showing a battery. It says up here a battery. It's showing a battery which is charging and discharging. What makes that interesting, or what makes that a little bit difficult, is they are going to jump around between it charging and it not charging, or charging and discharging. The point is, at one point, it's going to be galvanic, downhill, giving off electricity. Galvanic. So that's downhill on our electrochemical series. At another point in time, it's going to be electrolysis. It's going to be uphill. Now, for both of these cases, it's really important to remember that an oil rig cat is true. Um, an oil rig cat. They're true for both cases, but when it's galvanic, when it goes downhill, the cathode is negative and the anode is positive. And for the other one, all that changes is that sign there. We're going to have to be mucking around with both of these things, which is going to make this an interesting question. So stay tuned. Okay, the first question has given us something really important. It's given us two half equations which are not on the data book. Because they're not on the data book, you need to be very, very careful. Some really common tricks that they play here are just checking that your order is right. The order has to be from highest up the top down to lowest. One of the really common tricks examiners like to play is put these out of order, and you're going to have to switch them. It's always a good idea to rewrite them out if they do need to be switched. These, just to clarify, are in the right order. We've got the positive 1 up the top and the negative minus the negative 0.255 down the bottom. Therefore, they're in the right order. The second thing, much less used but still really nasty trick, is they put them in the wrong way round. It's always worth checking that the electrons are on the right side. The electrochemical series is always written so that every equation is written as a reduction. It's gaining electrons. This one is in the right way. So just to clarify, it is in the reduction format and it is highest to lowest. Therefore, it's all in the right order. That's a worthwhile thing to check first up anyway. So we have to state the polarity. It's asking for a plus or minus of each electrode as is being discharged. And discharged means it's galvanic. It means it's downhill. It means it's an oil rig cat. This is positive, this is negative. So just to clarify, if we go back here, electrode A is the one that's got these things, and electrode B is the one that's got these things involved. So if I go back here, this is B, this is B, and this was the A. So this thing's happening at A, this thing's happening at B. The one that we want to know is that this is downhill. It's downhill. It's discharge. So the idea is we're going to get a reaction between this stuff, and it's going to react with this thing, and it's going to be a downhill reaction. So this equation is going to go that way, and this equation is going to go that way. So the idea is that this stuff is going to gain electrons. Reduction is gain. This is happening at the cathode. This is positive. This one here is going to go the opposite way. Given it's the opposite way, it's oxidation. Oxidation as it loses these little electrons, so that's going to be the negative one. I hope that made sense. This is a really tricky question. So basically, it sparked debate because when is something fully charged? So if you think about your mobile phone, is it fully charged when it's still plugged in? You plug it in at night, you wake up in the morning, it's fully charged. If it's still plugged in, then it's electrolysis. If it's not plugged in yet, if you've just taken it out and it's got 100% charge, it's now galvanic. What that means is the examiners accepted two answers because they couldn't tell from this question what people were thinking. So the idea is if it's electrolysis, then it's going to be an uphill reaction. And if it's an uphill reaction, then this is reacting with that. Uphill reaction, this is reacting with that. Which means at the end of the day, you're going to get lots and lots and lots of this at this end, but this is reduction, that's gain, that's at the cathode. And this one here is the anode. So this is oxidation, and this is going to pump all night long, and it's going to produce these things here. So if it's still plugged in, we're going to accept this answer. On the other hand, though, if you've unplugged it, then you're going to have the opposite. You're going to have a downhill reaction. You're going to have this stuff here is going to react with this thing here. So if we have a look at what's happening here, now this is reduction up the top. So this is happening at the cathode, and this is the anode. This is going that way, this is going this way. We only care about the anode in this question. So as the anode's working all night, it's doing this, it's producing this, and it's going to produce tons and tons of this. So it's going to have lots and lots of this thing here at the end of the day. That means that there is two possible answers for this, and those two possible answers are different, and they're both acceptable, and they're both right. Okay, let's move on to the next one. Write a balanced overall equation for the reaction that occurs when it's being recharged. So recharged, it's electrolysis. It's uphill. So the idea is we are going to have this thing going that way. It's going to react with this thing, which is going to go that way. So I'm first of all just going to write them round in the right order. So the V3 one's in the right order, so I might just start with that. Oh, something's happened. Oh, I think it's frozen. Oh dear. Oh, we're back. Okay, so the V3 one is going to react with electrons to turn into V2 plus. One thing that you might be interested in there is that the arrow has now chosen a direction, because that's what happened. It actually is going this way now. It's not going either way, it's going just one of the ways. The other one's going the opposite way, so I'm going to rewrite this equation the right way round. VO2 plus H2O liquid turns into VO2 plus 2H plus and an electron. We have to do the overall equation, so we're going to join them together. So the thing you're looking for is that the number of electrons lines up, and in this case it does, so we don't have to multiply anything. So let's just, I'll pick a different color. We're going to add these two together. So everything I've got on the left is V3 plus an electron. I'll leave that in for now. VO2 plus a H2O, and then we put our arrow in, and we've got V2 plus VO2 plus 2 H pluses plus an electron. That is now our overall equation. We can now look to see if there's anything I can get rid of. Look for waters, look for hydrogens, look for that kind of thing. One thing that you have to make sure that is possible to cancel out is the electrons. So if we can cancel out the electrons, we've nailed it. So that's your overall equation. Let's go on to D. Written question, they're looking for some pretty standard answers here. So the written question is looking for what's the difference between this, what's one major difference in how a fuel cell is different to this cell. So the idea is that you need to know what the difference is between a fuel cell and this, which is just a rechargeable battery. So these things can be recharged. Fuel cells cannot be recharged. Fuel cells require constant flow of reactants. Either one of those, you probably need to explain it. I think it was only worth 1 mark, so they're probably only looking for something pretty simple there. Sentence, 4, 5, 6 words, whatever it is. Now, if I remember correctly, the actual question that came in was particularly about E. I did spend some time doing the other stuff. It says, write a balanced overall equation to show why iron would be unsuitable. So what's really interesting here is they're not asking you to tell me if it will be unsuitable. They're telling me it is. You don't have to try and know that it's going to be a bad one. You have to try and show how it is. And that's always a clue that you're going to be using the data book. Now, there's two reasons why something inside a galvanic cell is not going to help it. It's going to get in the way. And those two reasons are this. Number one is it will react instead. It's going to get in the way of the downhill reaction that we want to take place. It's going to somehow react instead of what we actually want. Or the other thing that you need to look for, this is the first one. Always look for this one first. The second thing that you might have to look for is to see if perhaps the Fe, in this case, or whatever, reacts with something else. So is there any ions in there that it will react with? Is there an acid in there? Will it make something that we don't like? Will it actually react and make something that we don't want in there, like maybe a solid or maybe some sort of gas? Look for things that you know explode. H2 is pretty explosive. Will it react and make something which is poisonous or dangerous? This is the number one to look at. The other one is if this doesn't work out. So we need to work out if iron is going to somehow interrupt what the reaction is that we want. So if we go down to our electrochemical series, I've taken the liberty of adding in these where they belong. So this is just a section, but this is going to be above here because of this number. And the other one that I've put in is this one in here. It's kind of hard to see, but it fits in between these two. The idea is if it's a galvanic reaction, it's going to go downhill. So what we actually want, or what the question wants us to do, is see that this is what the reaction is that we want. But if you have a look on the electrochemical series here, you might notice that there's iron there. Now this reaction, therefore, is going to be more likely. It's more downhill. So the answer that they're looking for in this is I want you to be able to say that Fe is a stronger reductant than your V2 plus. Basically, the Fe is lower down than the V2 plus. That's the point, but if you look back at the question, it actually says write a balanced equation for it. So basically, this top one is still going to do what it did. It's still going to go that way, but instead of reacting with this one down here, it's now going to react with the iron thing that we saw before. So the Fe solid, I'll just do it in, just imagine I've taken it off. Fe2 plus, it's 2 electrons, and we're now going to get this thing here reacting. So the two equations that we're going to get is that VO2 plus 2H plus, pick a side with your arrow. Oh, I forgot my electrons. Plus electrons, pick a side with the arrow. VO2 plus H2O. The other equation is going to be the iron one, but this time it's going to react like this. So it's going to go that way. So I'm going to stick in Fe solid. Pick a side with my arrow. Fe2 plus 2 electrons. And if we have a look on here, the thing that we're checking for is that the electrons line up, and in this case they don't, so I need to double this first one. Everything in there is going to be doubled. Let's see if I can get some stuff out of the way, just to give me some extra space. No, that didn't work. Okay. Okay, so if I'm now going to put them both together, I'm going to do 2VO2 plus 2H plus 2 electron. Oh, that's a 4. Sorry, did everyone see that? That's a 4. Plus Fe solid. And then we get an arrow, and the arrow goes to 2VO2 plus. Sorry, I just need a bit of space here. Let's get rid of that. Let's get rid of that too. Have I lost something? VO2. I actually needed that one, didn't I? Oh, what do I do with it? If you have a look at this, sorry guys, it's all going pear-shaped as my phone's ringing and everything's happening. So, so sorry. So that was 2H2O plus the ion down the bottom, which would have been Fe2 plus 2 electrons. Let's cancel out anything we can. So the 2 electrons can cancel out. Look for waters, look for H plus. There's nothing else in there. So your final answer for that one would be just a removal of these 2 electrons. And there is your overall equation. That's question 5 from the 2009 VCAR exam, and it's a really good one because it's something you might see again. Take care.